Reactions which are reversible, meaning reactants can change into products and then products can change back into reactants, have a double-headed arrow. The reaction can reach something called equilibrium. The definition of equilibrium is that the concentrations are constant, Cc, and that the rates are equal. What effect does adding a catalyst do to the position of equilibrium? A catalyst speeds up the rate of a reaction. Remember the definition? Concentrations are constant and rates are equal. So that means when we increase the rate of the forward reaction, this also increases the rate of the back reaction. So a catalyst does not change the position of the equilibrium. This past paper questions from the Higher 2017 multiple choice 20. Which line in the table best describes the effect of adding a catalyst to the following reaction? Remember, a catalyst speeds up the rate of a reaction. So that means that the rate of the forward reaction will increase. Remember our definition. The rates are equal. This means that the rate of the forward reaction and the back reaction would increase. So a catalyst does not change the position of the equilibrium. So the correct answer to this question is multiple choice answer B. Let's look at the effect of changing concentration on the position of the equilibrium. Now, concentration is associated with solutions, and the word solution ends in ions. We can see from the equilibrium that we've been given that they all are in the aqueous state, which stands for them being in a solution. At equilibrium, the colour of the solution is a light red colour. If the equilibrium moves to the right, that's for the product side, it will produce a dark red colour. And if the equilibrium moves to the left, that's towards the reactants, the colour of the solution would go colourless. So to change the position of equilibrium, we have to add or remove a particular substance. In this example, I'm going to add iron chloride, and we have to now change that into the ionic formula and identify the potential ions which could make a difference to the position of this equilibrium. So the two ions that we have from the ionic formula are the Fe3+ and the Cl-. If we take the iron ion first, we look to see if we have that in the equilibrium being provided in the question, which we do. So if we add to the reactant site, that means that it's going to change the position of the equilibrium and move it towards the right. Because if you've got more reactants, you can make more products. So the colour of the solution would change to a dark red. We then want to take our chloride ion, which is our Cl-. We can see that that's not present in our equilibrium mixture, but negative ions are attracted to positive ions. And this is where we have to use page 21 of our data booklet. The only positive ion which will be found on that page will be our Fe3+ ion. So if we look up iron 3 chloride, we can see that that's very soluble, which means that the ions stay in solution. That means that the chloride ion is a spectator ion, so will not change the position of the equilibrium. So the next substance that I'm going to add to see the change in the position of the equilibrium is KCNS. I need to change that into the ionic formula so that I can identify the two different ions that could be making a difference to the position of the equilibrium. So I've got K positive and CNS minus. If I take the K positive, I can see that it's not present in the equilibrium mixture. Positive ions are attracted to negative ions, and the only one that I have is CNS minus. If I use page 21, however, I don't have CNS minus in my data booklet, so I assume that that is a spectator ion and would make no difference to the position of the equilibrium. The next ion, however, is the CNS minus. I can see that that's present in my equilibrium mixture. I would be adding that ion to the reactant side, which would push the equilibrium to the right. More reactants means I can make more products. So the colour observed would be a dark red. So what would happen if we actually removed a particular ion? Let's take our CNS minus, and if I was to remove that from the equilibrium mixture, that means that the concentrations are no longer constant. This is going to change the position of equilibrium. I'm wanting to replace the CNS minus, which had been removed. This means that the position of equilibrium would move to the left, meaning that my product would break up to produce more of my CNS minus, which had been removed. This means that the colour which would be observed is colourless. When two aqueous solutions react, a precipitation reaction can occur, which makes an insoluble substance which will be removing the ions from the solution and therefore removing the ions from the equilibrium mixture. So let's add a substance such as barium chloride. I have to write the ionic formula for barium chloride to identify the ions which could be impacting the position of my equilibrium. I end up with a Ba2 plus ion and Cl minus ions in my solution. If I take the Ba2 plus, if I look at the equilibrium mixture, I do not have a barium found in that equilibrium, but positive ions are attracted to negative ions. The only negative ion that I have in the equilibrium is my sulfate. So if I use page 21 of my data booklet and I look up barium sulfate, I can see that that substance is insoluble. That means that it's going to remove the sulfate from the equilibrium mixture, which means the concentrations are no longer constant. This means that the position of the equilibrium would move to the right to try and replace the sulfate ions which had been removed. If we look at the chloride ions, again, that ion is not present in the equilibrium mixture. However, I know that negative ions are attracted to positive ions. The positive ion that I can see in my equilibrium mixture is my calcium ion. If I use page 21 and look that up, calcium chloride is very soluble, which means it's going to remain in solution, which means that the chloride ion acts as a spectator ion and it does not change the position of the equilibrium. This past paper questions from the revised higher 2018 multiple choice 25. The following equilibrium exists in bromine water. The red colour of bromine water would fade on adding a few drops of concentrated solution of what? Now what we've been given is 4 different formula, and because we're looking at solutions we have to change each of those into the ionic formula and identify if any changes the position of the equilibrium. So let's take hydrochloric acid. We'll write down the ionic formula, which means we end up with H plus and Cl minus ions. I have H plus ions which are found in my equilibrium, so I'd be adding to the product side, which changes the concentration. They're no longer constant. So this would push the equilibrium to the left. The next one down is potassium bromide. We'll write the ionic formula, which means the ions are K positive and Br minus. I look at my equilibrium, I can see that I do not have a K positive in my equilibrium. However, positive ions are attracted to negative ions. Using page 21, the only negative ion that it can combine with for me to problem solve is my bromide ion, that's a Br minus. And if I look up potassium bromide, I can see that it's very soluble, which means it's in solution, and therefore would act as a spectator ion and not change the position of equilibrium. If I take my bromide ion, Br minus, I can see that that is present in the equilibrium mixture. So I'd be increasing the concentration of my product side, which would push the position of the equilibrium to the left. Silver nitrate, we would write out the ionic formula again and identify that the ions were my Ag positive and my NO3 minus. If I look at my equilibrium mixture, I do not have a silver ion present there, but I know that positive ions are attracted to negative ions. Remember, using page 21, the only negative ion that I can use to problem solve is my bromide ion. When I look up silver bromide, I can see that that is insoluble. That means that the silver will remove the bromide ions by forming a precipitate. That means that the concentrations are no longer constant. and that the reactants are going to have to change into products to replace the bromide ions which have been removed. This changes the position of equilibrium to the right. So the correct answer to this question is multiple choice answer C. Water forms the most important equilibrium in chemistry, as water is a universal solvent that most substances are dissolved in to form solutions. Remember, a water molecule, which is in the liquid state, will break down to form H plus and OH minus ions. The definition is that a neutral substance has equal quantities of H plus and OH minus ions. When you add an acid, that's the H plus ions, to an equilibrium which has an OH minus ion present, it will remove the OH minus ions from the equation. Similarly, when you add a base, the OH minus ions will remove the H plus ions from an equation which contains those in the equilibrium mixture. Remember, H plus OH minus come together to form a molecule of water. This past paper questions from the Higher 2018 multiple choice 15. The addition of which of the following substances would move the above equilibrium to the right? Hydrogen is a diatomic molecule, it is covalently bonded, and it is not present in this equation, so would not make a difference to the position of equilibrium. If we take hydrogen chloride, we can write out the ionic formula and identify the two ions, which is H plus and Cl minus. We have a look at our equilibrium and we can see that both of those ions are found on the product side. If we add those ions, the position of the equilibrium will move to the left. The next substance we have is sodium chloride. So we write down the ionic formula and identify that we have Na positive and Cl minus ions. We can see that the Na positive is not present, but we know that positive ions are attracted to negative ions. If we look up page 21 and we look up sodium chloride, we can see that that is very soluble, so therefore would not change the position of equilibrium and the sodium would be a spectator ion. The chloride, the Cl minus, we can see is present in the product side, so adding that would change the position of the equilibrium to the left. We then have to do the same for sodium hydroxide. We write out the ionic formula and we can identify that we have our Na plus and OH minus. We already know that the sodium ions are spectator ions and therefore we have to use the OH minus ions. We can see that the OH minus ions are not present in the equilibrium, but negative ions are attracted to positive ions. That means that the OH minus will combine with the H plus ion and remove it to form a molecule of water. This means that the position of equilibrium would move to the right. So the correct answer to this past paper question is multiple choice answer D. This past paper questions from the Higher 2019 written 12C. In the bleach cleaner, an equilibrium exists. The label warns that the bleach cleaner should not be used with other products as it may release chlorine gas. Explain clearly why mixing the bleach with an acid would shift the equilibrium to the right, resulting in the release of chlorine gas from the bleach cleaner. So we can see that this past paper question is worth 2 marks, so we're going to have 2 points that we make, which is based on the key definition of an equilibrium. We need to speak about the concentrations and we need to speak about the rate. Now we know that acids have more H plus ions than OH minus ions. That means by adding the H plus ions, you will be increasing the concentration of the reactants. This means that it's going to push the position of the equilibrium to the right, making more of our chlorine gas.